Chapter 12 is about the regression line. First of all, let's remember back to our math classes, and any line can be described in terms of its slope and intercept. So you remember your slope-intercept form from your math classes. The equation of a line is y equals mx plus b, where m is your slope and b is your intercept. So in statistics, we'll usually just say y is our slope times x plus our intercept. The intercept, that's where it crosses the y-axis, so that's your y-intercept. And then for your slope, slope just tells you rise over run. So you go over so much and how much you go up. Or if you have a negative slope, so like here would be our y-intercept, and then the slope, if it's negative, it tells you go over and then down so much. For our regression line, there's an equation that we can use to find our slope and intercept. So the slope, again, is going to be our correlation times the standard deviation of y divided by the standard deviation of x. Our intercept, we can find that by the average of y minus the slope times the average of x. So let's try this. For example, 96, the summary data for a data set is, let's see, so for our x we have our average of 5.7, standard deviation of 1.9, and for y we have an average of 1.9 and a standard deviation of 1.6, and the correlation is r equals 0.7. So number one, find the equation, the regression line for estimating y from x. So the first thing we need to do is find our slope. And our slope is r times the standard deviation of y divided by the standard deviation of x. R is our correlation, that's 0.7. Our standard deviation for y is 1.6, and our standard deviation for x is 1.9. This gives me 5.89. So that's our slope. Now let's find our intercept. Our intercept, remember, is the average of y minus our slope times the average of x. So the average of y is 1.9 minus our slope, which is 5.89, times the average of x, which is 5.7. This gives me, let's back up a little bit. I just realized I made two mistakes here. So the slope, I wrote 5.89, but it was actually 0.589 for my slope. So that was just a mistake when also I realized when I was reading it that I wrote the standard deviation for x was 1.9 and the average for y was 1.9. That is not correct. That was just me accidentally typing the same thing twice. The average for y is actually 4.8. So now let's find our intercept with those new numbers. So the average of y is 4.8 minus my slope, which is 0.589, times the average for x, which is 5.7. This gives me 1.44. Now that I found my slope and intercept, I can just plug everything into the equation of my line. Remember, the equation of your line is y equals your slope times x plus the intercept. So in our case, y is going to equal 0.589 x plus our intercept of 1.44. Now let's graph the equation of our line on top of our scatter diagram. Okay, so this is our scatter plot. You can see the actual points. Here's my x, here's my y. Let's see how well we did our line. So first you find the intercept. Our intercept is 1.44. So you go up on the y-axis to about 1.44. So somewhere about here. So that's where I'm going to cross the y-axis. Then my slope, that's the higher part, so my slope is rise over run. So my slope is 0.589. That doesn't look like a fraction, but I could just write that over 1, and now it's a fraction. So this means I'm going to go over 1 and go up 0.589. Okay. So let's go over about 1 and up 0.589. So probably about to here. And then we'll go over 1 more and up about 0.589. Something about like this. And draw the equation of your line. Okay, so again we went over 1 and up 0.589. And there's the equation of our line. Notice that it seems to fit our points fairly well. It'd be even better if I had a more exact drawing and I was letting the computer do it instead of trying to do it myself by hand. Now, how can we use the equation of a regression line? It's very useful actually. We can use it to get predictions. All we have to do is put in our value for x and then we get out our predicted value of y. So again, the equation of our line is y equals our slope times x plus our intercept. If you put in an x value, then you get out the predicted y value. So let's try this. We have the summary data for a class's exams are, so you have your midterm and average, midterm and final, and you have the average and standard deviation for each, and then the correlation. So number 1, find the equation of the regression line. First we need to find our slope. Again, slope is r times the standard deviation of y over the standard deviation of x. So r is 0.7. Let's see. It didn't tell me yet which way I'm predicting. Let's scroll down and check. Estimate the final exam score. So we want to predict the final exam score. So that's our y, and then midterm is our x. Remember, whatever you're trying to predict is always your y. So 0.7 is our correlation, and then the standard deviation of y, that's 10, divided by the standard deviation of x, which is 16. And this gives me 0.44. Now let's find our y-intercept. Our intercept is the average of all the y's minus the slope times the average of all the x's. So the average of y is 60 minus my slope of 0.44 times the average of the x's, which is 65. This is 31.4. So we have our slope, we have our intercept. Now if we put these two things together, we can write the equation of our line. So my line is going to be y equals my slope times x plus the intercept. So in our case, y equals our slope, so 0.44 times x plus the intercept of 31.4. Technically, that is your final answer. You most certainly may leave your answer in this format. For myself, I prefer, if there is a context to the problem, to write the equation of the line in the context of the problem. So in our situation, what were the x and y's? So y is final and x is midterm. So I can rewrite this as the final grade equals 0.44 times the midterm grade plus 31.4. So either one of these answers would be acceptable. They're both technically correct. However, I like the one that has a little more context. That helps me later on. It's just a little bit easier to work with. So now number 2, estimate the final exam score for someone who got a 50 on the midterm. Okay, so that means our midterm equals 50, or if you prefer, that means that x equals 50. But now all I have to do is plug that into the equation of my line. So your final equals 0.44 times the midterm plus 31.4. So now we're just going to plug 50 into the score for the midterm. So our final is going to be 0.44 times 50 plus 31.4. Which is 53.4. What does this mean to us? This means that if someone gets a 50 on the midterm, we predict they will get about 53.4 on the final. Notice this is the exact same thing we did with the regression method back in chapter 10, but this is actually a little bit easier and faster to do. So let's try our next one. Let's estimate the final exam score for someone who got an 80 on the midterm. So that just means that the midterm score equals 80, or x equals 80. And you can use either equation in line. Just so that you can see it, I'll say that I didn't write in context, and I'll just use my y and x format. So y equals 0.44 x plus 31.4. So all I have to do is just plug in the x equals 80. So y equals 0.44 times 80 plus 31.4, which is 66.6. Once again, this means that if someone gets 80 on the midterm, we predict that they will get about 66.6 on the final. Example 98, we're just going to do the same thing. So our following, this is hypothetical data, summarizes the relationship between IQ scores and head circumference. The average IQ score is 100, the standard deviation is 15, the average circumference is 21, the standard deviation is 0.75, and R is 0.6. So we want to find and interpret the slope of the regression line for predicting head circumference from IQ. First, let's make ourselves a note that y is always the variable you want to predict. So in our circumstance, we want to predict head circumference. So x is IQ and y is head circumference. So number one, find the slope. My slope is equal to r times the standard deviation of y over the standard deviation of x. So our correlation is 0.6. Our standard deviation of y, so remember y is head circumference, so standard deviation of head circumference is 0.75. And divide by the standard deviation of x. Standard deviation of IQ scores is 15. This gives me 0.03. Now we need to interpret it. To interpret the slope, we need to remember that slope equals rise over run. So in our case, we have a rise of 0.03 over 1. Or if you want, you could change, like multiply top and bottom by 100. Because if you multiply by 100 over 100, you're really just multiplying by 1. So this just gives me like 3 out of 100. And so what does this tell us? This tells us that associated with an increase of 100 IQ points, we would expect, or associated with an increase of 100 IQ points is an increase of 3 inches in head circumference. Or for our slope, instead of timesing it by 100 over 100, I could have maybe just times it by 10 over 10, so this could have been like 0.3 over 10. Or, so we could have done 0.03 over 1, or 0.3 over 10, or 3 out of 100. Any way you want to do it, that works. I'm going to write it another way. So I could say, if IQ goes up by, now let's do the 0.3 over 10, goes up by 10 points, we expect the average head circumference to increase by about 0.3 inches. You will notice that the first interpretation where I said associated with an increase of 100 IQ points is an increase of 3 inches in head circumference. And this might sound a little silly to word it that way, but it's trying to help us remember that this is just an association. We're not actually doing a cause and effect. So we can't say that if the IQ is going up 100 points, then your head will increase by 3 inches in head circumference, because it might not be a cause and effect. So instead we just say associated with. Or this is all just working on average. So if the IQ goes up by 10 points, we expect the average head circumference to increase by about 0.3 inches. So this doesn't necessarily tell us what's going to happen for individual people, but we can predict on average what might happen. Number 2, let's find and interpret the intercept for the regression line for predicting head circumference from IQ. So again, your intercept equals your slope times x. No, that's the wrong thing. Your intercept is the average of y minus your slope times the average of x. The average of y, so our circumference is 21 inches. Our slope we just found is 0.03. And our average for x's, average IQ score, is 100. This gives me 18. Okay, how do we interpret this? Remember, your intercept is the y value when x is 0. If I was to try and interpret that, then it's going to mean something like, so if x, or if the IQ score, so if the IQ score is 0, then the predicted head circumference is 18 inches. Now this might not be a very logical interpretation because people might never have an IQ score of 0. And we'll talk a little bit later on about how our intercepts don't necessarily need to have a logical interpretation. Number 3, let's find the regression line for predicting our head circumference from IQ. So now we just need to write the equation of the line. Y equals your slope times x plus the intercept. So y equals our slope of 0.03 times x plus our intercept of 18. And again, you can write it in context. So y is head circumference. So I could say circumference equals 0.03 times x is IQ score, plus 18. And writing it in context just helps us a little further on when we're trying to predict. Number 4, let's use the regression line to predict the head circumference of a person with an IQ of 90 points. So that just means that x equals 90, or IQ equals 90. We just need to plug that number into the equation of our line. So again, our circumference equals 0.03 times IQ plus 18. So the head circumference is going to be 0.03 times the IQ of 90 plus 18. This gives me 20.7 inches. So if they have an IQ score of 90, we predict their head circumference will be 20.7 inches. Number 5, use the regression line to predict the head circumference of a person with an IQ of 110 points. So this means that x is 110, or if you prefer, IQ equals 110. I'm going to use just the y form of the equation, just for practice. So all I have to do is plug in x is 110. And this gives me 21.3 inches. So the predicted head circumference is 21.3 inches. And number 6, we expect the prediction to be off by about how many inches? This takes us back to chapter 11, because remember, we expect the predictions to be off by about 1 RMS error. So to answer this, we need to find our RMS error. The RMS error is the square root of 1 minus r squared times the standard deviation of y. So this is going to be the square root of 1 minus, let's go back up and see what our correlation was. Our correlation was 0.6, and the standard deviation for y is 0.75. So it's going to be 1 minus 0.6 squared times the standard deviation of y, which is 0.75. When I put this in my calculator, just coincidentally, it ends up being 0.6 inches. So we expect our prediction to be off by about 0.6 inches. And finally, what are the advantages of using a regression line versus the regression method? Remember what the regression method was? We had to figure out how many standard deviations our x was above the x average, then times that by r, and then we were that many standard deviations away from the y average. So the advantages of using the regression line is that your predictions with the equation of the line are faster. Especially if you have to do more than one prediction, because you only have to find the equation of the line once. That's the hard part, and then you can just plug in your x values to make your predictions, and that's very quick and easy. And because you're doing less work, you're probably less likely to make mistakes while calculating. And the regression line is much more common in practice than the regression method. So the regression method does work, but in practice, if you're ever to use this in your job or in another class, you're much more likely to use the regression line than the regression method.